Hello everyone. Today we are going to learn an important topic from Class 12 Electronics Operational Amplifier, also known as OPAMP. This topic is very important not only for board exams, but also for fields like electronics engineering, robotics, circuit design, and VLSI. In this presentation, we will understand OPAMP from basic concepts to practical applications in a simple way. Introduction. First, let us understand what an operational amplifier is. An operational amplifier is an integrated circuit, IC. Its main function is to amplify voltage signals. It is a very high gain amplifier, which means it can increase even a very small signal. Because of this, it is commonly called an OPAMP. Today, OPAMPs are used in many electronic devices such as audio systems, sensors, medical equipment, and communication circuits. Symbol of OPAMP. Now let us understand the symbol of an OPAMP. In circuit diagrams, an OPAMP is represented by a triangle shape. It has two input terminals, one output terminal. The two inputs are inverting input, non-inverting input plus. It also has power supply terminals, plus V. These power supplies help the OPAMP operate properly. Basic terminals. Now let us look at the basic terminals of an OPAMP. An OPAMP has two input terminals, plus and one output terminal. Power supply terminals, plus VCC and VCC. The output of the OPAMP depends on the difference between the two input voltages. This is the most important concept of OPAMPs. 5. Working principle. Now let us understand the working principle of an OPAMP. The output voltage is given by the formula Vout is equal to A, V plus V, where V plus is equal to non-inverting input, V is equal to inverting input, A is equal to open loop gain. Since the gain is very high, even a small difference between inputs produces a large output. Ideal OPAMP characteristics. Now we will discuss the ideal OPAMP. An ideal OPAMP is a theoretical model used for understanding circuits. It has the following characteristics: infinite gain, infinite input impedance, zero output impedance, infinite bandwidth, zero offset voltage. In real life, these conditions are not possible, but they help us analyze circuits easily. Practical OPAMP characteristics. Now let us look at the practical OPAMP. In real OPAMPs, gain is very high but not infinite. Input impedance is high. Output impedance is low. Bandwidth is limited. So practical OPAMPs have some limitations compared to ideal ones. Open loop configuration. Next, we study open loop configuration. In this configuration, no feedback is used. Gain is extremely high. Output saturates quickly. Because of this, open loop configuration is mainly used as a comparator. A comparator compares two signals and gives output based on which one is higher. Closed loop configuration. Now let us understand closed loop configuration. In this configuration, feedback is used. Gain can be controlled. Circuit becomes stable. That is why closed loop configuration is widely used in amplifier circuits. Most practical OPAMP circuits use closed loop configuration. Inverting amplifier. Now we will discuss the inverting amplifier. In this configuration, the input signal is applied to the inverting terminal. The non-inverting terminal, plus, is connected to ground. The output signal becomes inverted, meaning it is opposite in phase to the input. The gain formula is gain is equal to RFRin. The negative sign indicates inversion. Non-inverting amplifier. Next is the non-inverting amplifier. Here, the input signal is applied to the non-inverting terminal plus. The output signal remains in the same phase as the input. The gain formula is gain is equal to 1 plus RFRin. This type of amplifier is widely used in practical circuits. Voltage follower. Now let us understand the voltage follower. It is a special case of the non-inverting amplifier. In this case, gain is equal to 1. This means the output voltage is exactly equal to the input voltage. A voltage follow is used as a buffer circuit. It helps in signal isolation. Applications of op-amp. Now let us see the applications of op-amps. Op-amps are used in amplifiers, oscillators, filters, voltage regulators, comparator circuits. They are one of the most important components in modern electronics. Advantages. Now let us discuss the advantages of op-amps. High gain, small size, low cost, reliable operation. Because of these advantages, op-amps are widely used in electronic systems. Limitations. Now we will look at some limitations of op-amps. Limited bandwidth. Noise. Requires power supply. Real circuits are not ideal. Therefore, engineers must consider these limitations when designing circuits. Summary. Let us summarize what we learned today. An operational amplifier is a powerful integrated circuit. It works based on the difference between two input voltages. It is widely used in many electronic circuits. This topic is very important for exams, projects, and future studies in electronics. Before we end, here is a question for you. If an op-amp has very high gain, why do we still use closed-loop configuration? Think about it. Thank you for watching and learning. In the next lecture, we will discuss op-amp circuits and numerical problems.